देखो चीज़ नहीं कहेगा.
Hello everyone and welcome back to SK Vanikis and we're back again with another live stream that we have here. And आज की जो हमारी लाइव स्ट्रीमिंग होगी हम लोगों ने एक्चुअल में एक स्पेसिफिक टॉपिक सेट करके रखा है एंड इट्स गोना बी रिलेटिविटी. वेल दैट इज़ व्हाट कम्स from the top of your head or the tip of your tongue when you are talking topics that we can discuss and interact and learn more about when we are discussing specifically. So we are gonna be discussing about it. I'll just wait for some people and we are gonna do it then. There's some people already, I suppose. Whoever's coming. Quanta thinks, what is time? And well, that has been the best way to start the discussion. कि time क्या होता है? Well, time is something that is very controversial when it comes even in the physical community or the scientific theories. So the thing is कि here I'll just take a breath from relativity and rather let's get into a little quantum physics. Quantum physics जब हम लोग solve करते हैं तो here we consider कि time universally flow करता है and it is something जो कि बस universally flow कर रहा है and even in Newtonian physics so. And it is something like a background parameter as to quote in the lines of Wikipedia. लेकिन जब relativity किया जाता है so time is considered to be a dimension. इट्स लाइक जैसे यू आर मूविंग फॉरवर्ड थ्रू स्पेस, आप स्पेस के थ्रू चल सकते हो. द सेम वे यू कैन ऑल्सो मूव थ्रू टाइम एंड इन फैक्ट द सेम वे आर कंटिन्यूसली मूविंग थ्रू टाइम. एंड इट इज़ वेरी इंटरेस्टिंग व्हेन इट कम्स टू दिस कि हम सब लोग हमेशा हमेशा स्पीड ऑफ लाइट पे चलते हैं बट वी आर मूविंग थ्रू स्पीड ऑफ लाइट थ्रू स्पेस प्लस टाइम. सो जब हम लोग कम्प्लीटली स्टैटिक हैं तब हम लोग एक्चुअल में टाइम के थ्रू स्पीड ऑफ लाइट से एज कर रहे हैं. सो वेल वी एज ऑफ कोर्स एवरीथिंग एजेस एट व्हाट स्पीड? द स्पीड ऑफ लाइट थ्रू टाइम. बट व्हेन वी मूव तब हमें क्लियरली पता है कि हमारी जो यूनिवर्सल स्पीड है वो स्पीड ऑफ लाइट है. लेकिन जब हम लोग स्पेस के थ्रू चलते हैं अपने एक्स वाई या जेड डायमेंशन के अलोंग चलते हैं द लेंथ ब्रेड्थ और हाइट, तब ये स्पीड हमें कहीं से मिलनी चाहिए बिकॉज दिस इज एक्चुअली अ कंजर्व्ड क्वांटिटी टू से दो दैट इज़ नॉट इन अ वेरी स्ट्रिक्ट सेंस एज इन द लिटरल सेंस ऑफ द वर्ड्स. तो ये जो हमें स्पीड मिलती है ये हमारी जो टाइम की स्पीड है वहाँ से थोड़ी स्पीड कट ऑफ होती है एंड स्पेस डायरेक्शन में जाती है. दैट इज़ द एसेंशियल फेनोमेना ऑफ लेंथ टाइम डायलेशन. टाइम डायलेट क्यों करते हैं, स्लो क्यों करते हैं व्हेन वी मूव? क्योंकि जब हम लोग स्पेस में चलते हैं तो हमारी जो टाइम के थ्रू स्पीड है वो कम होती है एंड वो ऐड होती है स्पेस की स्पीड के थ्रू एंड दैट इज़ वाई टाइम डायलेशन ऑकर्स. सो time itself to define is of course one of the big questions of physics. As in the context of relativity we say it is a dimension that we are all moving through at all the times except things that move at speed of light. जो चीज़ें लाइट की स्पीड से स्पेस में चलती हैं, जो स्पेस में लाइट की स्पीड से अपीयर करती हैं चलना, मतलब वो टाइम के थ्रू नहीं चल रही हैं बिकॉज द टोटल स्पीड ऑफ एनी थिंग थ्रू स्पेस एंड टाइम कैन ओनली बी 3 into 10 power 8 meter per second. That is the reason photons कभी एज नहीं करते हैं. So photons are always the same seconds old. In fact, they are not exactly born in the typical sense. So photons are always ageless. Gaming Zeraora, what are the advantages and disadvantages between using photons as qubits instead of classical logic qubits? So I think you wanted to say classical logic bits. The thing is that when we are using things as quantum bits, so you're using photons as quantum bits, what you're doing is you're actually writing it in your equations कि एक superposition of states exist कर सकती है. Even though her topic of the stream was relativity, but we are getting a little quantum here. सो चीज़ें सुपर पोजिशन में एग्जिस्ट कर सकती हैं एंड व्हाट दैट मीन्स इन क्वांटम फिजिक्स इज कि एक चीज़ इस स्टेटमेंट इस स्टेट में साथ में एग्जिस्ट कर रही है. सो एक इलेक्ट्रॉन है फॉर इंस्टेंस, एक इलेक्ट्रॉन स्पिन अप और स्पिन डाउन साथ में कर रहा है. सो इट इज़ ऑल्सो स्पिन अप ऑल्सो स्पिन डाउन अनलेस अंटिल इट इज़ इंटरैक्टिंग विद द मेजरिंग इंस्ट्रूमेंट्स दैट मे बी विल आर आई कि हम लोग इस इलेक्ट्रॉन को देख रहे हैं या फिर कोई दूसरा हम लोग मेजरमेंट करें जिससे उसकी इंटरेक्शन होती है नेचर के दूसरी चीज़ों के साथ. सो जब हम लोग उस इलेक्ट्रॉन को मेजर कर रहे हैं उसके स्पिन को मेजर करने की कोशिश कर रहे हैं. सो यू आर बेसिकली सेइंग कि हम लोग कुछ तो वहाँ पे कर रहे हैं जिससे वहाँ का जो एक फोटोन है हमारी आई में जा रहा है, या फिर उस इलेक्ट्रॉन से कुछ इंटरैक्ट करें एंड बाद में कहीं मेजरिंग डिटेक्टर में जा रहा है, राइट. सो जब ये होता है तब ये सुपरपोजिशन ब्रेक हो जाते हैं उस इंस्टेंट के लिए, एंड ये इलेक्ट्रॉन एक स्पेसिफिक स्टेट में आ जाते हैं. बट व्हेन यू आर नॉट डूइंग दैट, सो यू नीड टू रिप्रेजेंट फोटोन और एनीथिंग सच, एनी सच क्वांटम पार्टिकल की एक्चुअल में सुपरपोजिशन ऑफ स्टेट्स में है. एंड दैट इज वाई यू आर यूजिंग क्वांटम बिट्स, because it can have well a state of 0 and a state of 1 simultaneously. That is how you do it, right? You have zeros and ones. So that is basically happening simultaneously, and that is why you use quantum bits uh, in contrast with classical bits, because it's all happening simultaneously. Now, Maggo, why, Maggo, is quantum physics explain relativity? Can quantum physics explain relativity? Well, actually, I think that there are various things that are still in contradictions with quantum mechanics and relativity, especially when it concerns general relativity. तो वहाँ पे क्वांटम मैकेनिक्स अभी तक ग्रेविटी को अच्छे से एक्सप्लेन नहीं कर सकती है, दैट व्हाट एग्जैक्टली इज ग्रेविटी. बिकॉज जब आप एक क्वांटम थ्योरी ऑफ ग्रेविटी कंसिडर करते हो, सो आवर करंट मॉडल्स ऑफ क्वांटम ग्रेविटी, तो यहाँ पे कुछ ऐसे इन्फिनिटीज अराइज करते हैं सच एंड सच विच कांट जस्ट बी सॉल्व्ड, राइट. सो दैट इज़ द थिंग कि हम लोग क्वांटम ग्रेविटी को तो नहीं समझ सकते. व्हेन इट कम्स विथ यूनिफाइंग क्वांटम मैकेनिकल लॉज with special relativity, then you come to across these quantum field theories. Quantum field theories well चीज़ों को solve करती है, but still I don't think that it actually explains everything behind relativity that well, क्योंकि special relativity भी एक special case है, एक limiting case है general relativity का, and that it can explain special relativity, not general relativity. So says that there are still flaws in quantum mechanics, and there have to be, क्योंकि अभी तक टाइम का ये पैराडॉक्स अबाउट द ट्रू नेचर ऑफ टाइम, क्या ये एक बैकग्राउंड पैरामीटर है या फिर इज इट समथिंग रियली रिलेटिव. So there are still questions regarding this that haven't been solved. So yes, it has been consistent with the special relativity, as in the sense that there we have quantum field theories, but we still haven't understood quantum mechanics completely well to derive just everything with this particular thing. जेपी जीनियस बॉय, क्या रामानुजन पैराडॉक्स सही है? इन्फिनिट इक्वल्स -1/12. That is something that I haven't understood very much myself, as I haven't studied a lot of pure mathematics, to be very honest. Rather, I have studied mathematics that is going to help me in studying more physics. तो जो मुझे फ़िज़िक्स में हेल्प करती है, मैंने बेसिकली वही मैथमेटिक्स पढ़ा है. तो जो मुझे फ़िज़िक्स में हेल्प कर रही है, जो प्योर मैथमेटिक्स है, मैंने नहीं पढ़ा है उतना. सो कंसिडरिंग दैट मुझे एग्जैक्टली इसके बारे में आइडिया नहीं है, बट ये ऐसे उस सेंस में भी नहीं सही है जिसमें आप सोचते हो कि अगर आपने डायरेक्टली ऐसे ऐड कर ही दिया तो एग्जैक्टली लिटरली आपको सम -1/12 मिलेगा, क्योंकि ये बेसिकली हमारे एरिथमेटिक के लॉज को भी वायलेट करता है. तो ये उस सेंस में एक्चुअली सही नहीं है. दैट इज़, आई कैन प्रेटी श्योरली से, it is not in that correct in that sense. Rather, there must be some other meaning behind it. Gaming Zeraura, Sarim, I can explain why it comes out as -1/12. Where can I explain it to you? Any email? Try explaining it here if you can, and I'll be really pleased if you do. Or in any other case, you can just explain it to me on email. अब वो आपको चैनल के अबाउट सेक्शन में मिल जाएगा. You can go to the about channel section and you can find the email. I can even speak it here. It's mohassinkhan25@gmail.com. So you can just check it in channel about section, explain it there, or I would be pleased if you even explain it here. Cyber Hydra, sir, I want to learn physics from starting to end. How do I learn, sir? Please help me. Currently, I'm in cyber security field. I want to become astrophysicist. So, well, to learn physics from starting to end, well, there are these great number of tips that you can always take from different kind of people, and you can try learning physics. But the thing is that that you need to start somewhere. कहीं ना कहीं आपको शुरू करना है, and that is the main problem that we are all about कि हम लोग ये करेंगे and we are confused, ये कर देंगे या फिर ये करेंगे, यहाँ से शुरू करेंगे या फिर यहाँ से. So that is basically what's the problem, and we don't exactly start it. So you need to take out time and you need to start doing it. You need to start doing physics. That is how you'll start it. I mean, just start it. So that's the thing. And in fact, एक जो problem, and it took me in fact 3 years to actually learn this thing, and today also I was just telling it to my dad that it took me 3 years to know about this thing, and I deeply can't emphasize enough on this point कि जो प्रॉब्लम सॉल्विंग होती है ये बहुत ही इंपॉर्टेंट एस्पेक्ट होता है फिज़िक्स सीखने का. इनफैक्ट जो प्रॉब्लम सॉल्विंग होती है वो उतना अच्छा मेजर नहीं होता है कि किसी पर्सन को कितना फिज़िक्स आता है. आई वुड से दैट कि ये इतना अच्छा मेजर नहीं है कि किसी पर्सन को कितना फिज़िक्स आता है. सो इट डजेंट एग्जैक्टली मेजर कि आपको कितना फिजिक्स आते हैं, वेदर यू कैन सॉल्व दिस प्रॉब्लम और नॉट. सो अकॉर्डिंग टू दैट यू नो द कंसेप्ट और नॉट. बट रादर जो प्रॉब्लम सॉल्विंग होती है, जैसे आप क्वेश्चन सॉल्व करते हो, प्रॉब्लम सॉल्व करते हो, एक्सरसाइजेस, सो दे टीच यू फिजिक्स, एंड दैट इज द मेन मोटिव बिहाइंड द प्रेजेंस ऑफ प्रॉब्लम्स एट द एंड ऑफ टेक्स्ट बुक्स. कि they are there to teach you physics, not to test your physics, and that is how you should take it. So you can learn a lot of physics by solving those problems. So you need to learn how to solve those problems, and when you learn it, you can't basically do this thing right here. एक यहाँ पे प्रॉब्लम है, आप नहीं कर सकते हो. So you go back to the section जो कि टेक्स्ट बुक में वहाँ पे था, and you reread that again, and you keep thinking about that, and it strikes somewhere. So that thing is very important. I just recommend to everyone. प्रॉब्लम्स को इसलिए नहीं करो कि वो आपकी एबिलिटीज़ टेस्ट करें, बल्कि वो आपको एबिलिटीज़ देंगे. सो दैट इज़ वन वेरी इंपॉर्टेंट थिंग व्हाइल लर्निंग फिजिक्स. Okay. Wait a minute. Okay, gaming Zeraora. Actually, when Ramanujan takes something common, extra terms are added. Example, if you take a series of 1 minus 1 plus 1 minus 1 and factor minus 1, then there is an extra terms at the far right of the never-ending series. So the result minus 1 over 12 is actually the average of all possible results. The kind of touched quantum superposition. Oh, really a great way of explaining it, I would say. So I think I get it. So it's like an average. That word certainly, I think, makes sense when you consider it from the quantum mechanical perspective. So I think that makes sense. I will think more about it, and I think it will really click to me in that way. Raj, explain about quantum physics. Well, quantum physics is something that is truly difficult to explain, I would say. So it's like you can consider जो जैसे आप relativity को explain कर सकते हो, या फिर न्यूटनियन मैकेनिक्स या फिर मैक्सवेल्स इलेक्ट्रोडायनेमिक्स को explain कर सकते हो. I would say it is difficult to explain the laws of quantum mechanics like this, but I would say the simplest things, जो simplest principles I would say is something like this. Let's consider Feynman's version of quantum mechanics. Feynman के जो quantum mechanics है, the path integral formulation इसे कहा जाता है. What it says is कि जो हमारे particles होते हैं, let's say you have a room या फिर you have a certain box, एंड इस बॉक्स में मैंने कुछ बहुत ही छोटे पार्टिकल्स को रखा है, जैसे इलेक्ट्रॉन्स हो गए या प्रोटॉन्स हो गए. एंड ये जो इलेक्ट्रॉन्स फॉर इंस्टेंस हैं, एंड दे आर हॉपिंग फ्रॉम प्लेस टू प्लेस. एक बॉक्स में इन्हें रखा गया, एंड ये इलेक्ट्रॉन मुझे पता है कि मैंने इसे यहाँ पे रखा था, एंड मैंने क्लोज द बॉक्स एंड मुझे नहीं दिख रहा है वो इलेक्ट्रॉन का है, तो वो इलेक्ट्रॉन बेसिकली कंटिन्यूसली इधर उधर हॉप करते हैं इन सम बेसिकली अनसिविलाइज्ड वे। एंड ये जो प्रोबेबिलिटी है कि ये इलेक्ट्रॉन एक इंस्टेंट पे यहाँ पे है तो दूसरे इंस्टेंट पे यहाँ पे होगा, इस प्रोबेबिलिटी को कैलकुलेट किया जा सकता है। कैसे करते हो? वेल एस्यूम कि एक इंस्टेंट पे इलेक्ट्रॉन यहाँ पे एंड यू वांट टू नो कि व्हाट इज़ द प्रोबेबिलिटी, क्योंकि एग्जैक्टली ये कहाँ पे होगा नेक्स्ट इंस्टेंट में इसे कैलकुलेट नहीं किया जा सकता, क्योंकि वेल इट इज़ कंसिडर्ड व्हेन यू आर नॉट ओपनिंग द बॉक्स और डूइंग और इंटरेक्टिंग विद दैट थिंग, ये इलेक्ट्रॉन हर जगह साथ में है। सो ये हर जगह साथ में, इट इज़ कॉल्ड अ सुपर पोजिशन ऑफ स्टेट्स, नॉट एग्जैक्टली द सुपर पोजिशन ऑफ स्टेट थिंग। सो वॉट यू कैन ओनली गिव द प्रोबेबिलिटी एक इंस्टेंट यहाँ पे दूसरा इंस्टेंट यहाँ पे होगा। And how is that calculated? Well, you calculate this certain thing called action of the particle. What is the action? The action is this integral with respect to time of the difference of kinetic energy of the particle and the potential energy. Well, potential energy of the particle and this other things जिसके साथ interact करे. So I'm pretty sure you know about kinetic and potential energies. I am assuming that you subtract them and you integrate विद रिस्पेक्ट टू टाइम कि इस इंस्टेंट पे यहाँ पे तो दूसरे किस इंस्टेंट पे इसे यहाँ पे कैलकुलेट करना है कि यहाँ पे होगा। सो एट वन इंस्टेंट दैट इज़ द लोअर लिमिट ऑफ इंटीग्रेशन, द सेकेंड इंस्टेंट जो यहाँ पे द अपर लिमिट ऑफ इंटीग्रेशन, दिस इज द एक्शन। एंड यू से कि आप एक्शन कैलकुलेट करते हो फॉर वन पाथ कि ये इलेक्ट्रॉन यहाँ से यहाँ इस पाथ के थ्रू जा सकता है, ये इलेक्ट्रॉन यहाँ से यहाँ इस पाथ के थ्रू भी जा सकते हैं एंड इस पाथ के थ्रू भी जा सकते हैं एंड ऐसे इन्फाइनाइट पाथ्स हो सकते हैं। तो आप ऐसा हर पाथ फॉर गोइंग फ्रॉम दिस पॉइंट टू दिस पॉइंट कैलकुलेट करते हो, हर पाथ के लिए एक्शन कैलकुलेट करते हो एंड उन सारे एक्शंस को ऐड करते हो एंड व्हेन यू ऐड देम अप सो आपको एक्चुअल में प्रोबेबिलिटी मिल जाती है बाय एडिंग अप द एक्शंस कि व्हाट इज़ द प्रोबेबिलिटी दैट द इलेक्ट्रॉन इज गोइंग फ्रॉम हियर टू हियर। इनफैक्ट आपको डायरेक्टली प्रोबेबिलिटी नहीं मिलती है, यू रादर गेट जो आप प्रोबेबिलिटी एम्पलीट्यूड कहते हो एंड यू गेट दिस प्रोबेबिलिटी एम्पलीट्यूड एंड वेल आपको अब बस क्या करना है, कॉम्प्लेक्स नंबर होता है, आपको इससे स्क्वेयर कर देना है, इसकी मैग्नीट्यूड को स्क्वेयर करना है, दैट इज़ द प्रोबेबिलिटी। सो दिस इज फाइनमैन्स वर्जन ऑफ क्वांटम मैकेनिक्स, द पाथ इंटीग्रल फॉर्मुलेशन। Raj, what is relation between quantum physics with chemicals? So I think you mean chemistry. Well, this is something, in fact मैंने university physics I think में पढ़ा था and that thing has kept me striked till day कि some physicists claim that all of chemistry can be derived from the Schrödinger equation. The thing is कि quantum mechanics के quantum physics के जो laws हैं deep down they are all at work and ये सारे बेसिकली क्वांटम मैकेनिक्स के लॉज काम करते हैं बाय वॉट एवर आई एक्सप्लेन द फाइनमैन्स पाथ इंटीग्रल फॉर्मुलेशन। सो देर आर अदर वेज ऑफ डूइंग क्वांटम मैकेनिक्स जैसे श्रोडिंगर्स वेव मैकेनिक्स और हाइजेनबर्ग्स मैट्रिक्स मैकेनिक्स फॉर इंस्टेंस। तो इफ़ यू कंसिडर श्रोडिंगर्स वेव मैकेनिक्स जो कि श्रोडिंगर इक्वेशन सॉल्व करके हम लोग क्वांटम मैकेनिकल लॉज को लिखते हैं। सो वॉट बेसिकली हैपन्स इज कि किसी भी केमिकल के लिए वॉट इज़ इट एट द एंड ऑफ द डे, इट इज़ बेसिकली अ कॉम्पोजिशन ऑफ वेरियस एटम्स एंड मॉलिक्यूल्स एंड दैट इट इज़ अ कॉम्पोजिशन ऑफ वेरियस एटम्स एंड मॉलिक्यूल्स जो कि एक दूसरे के साथ इंटरैक्ट कर रहे हैं कंटिन्यूसली। सो इस इंटरैक्शन को आप कैसे डिस्क्राइब कर सकते हो? एक एटम के मोशन की डिस्क्रिप्शन हो सकती है क्वांटम मैकेनिकल लॉ से एंड दैट इज़ हाउ इट नीड्स टू बी डन। तो वेरियस एटम की डिस्क्रिप्शन होगी क्वांटम मैकेनिकल लॉ से फॉर ऑल दीज एटम्स एंड हाउ दे इंटरेक्ट विथ ईच अदर एंड हाउ दिस इंटरेक्ट विथ एटम्स एंड मॉलिक्यूल्स ऑफ अदर सब्सटेंस। सो यू आर बेसिकली यूजिंग क्वांटम मैकेनिकल लॉज ऑल द टाइम जब आप केमिस्ट्री कर रहे हो। सो इट इज़ that you are using quantum mechanics but you are using at a macroscopic level जहाँ पे आप अपनी केमिस्ट्री के प्रैक्टिकल्स में अपनी केमिस्ट्री के लैब में जब सॉल्यूशंस मिक्स कर रहे हो डीप डाउन अगर आप एक एक एटम को देखोगे तो वो क्वांटम मैकेनिक्स के लॉज यूज़ कर रहे हैं टू इंटरैक्ट विद द एटम्स ऑफ द अदर सब्सटेंस बट यू वॉन्ट नोटिस इट। आपको आपके मैक्रोस्कोपिक केमिस्ट्री लॉज दिखेंगे बिकॉज वेल when you have zoomed out of the picture so much कि there are billions of atoms interacting with each other all at once, so काफ़ी effects cancel out हो जाते हैं, right? So there are so many effects जो कि cancel out हो जाते हैं, and so you'll see this thing. Raj, thanks for explanation. I'm from Bihar, Chhapra. You're welcome.
ट्राई टू स्पीक हिंदी मैक्सिमम। अभी देखो बहुत लोग हुए हैं।
An angel is our Earth center of universe. Well, as far as we know, no, it's not. The Vena, are you preparing for JEE? No, I'm not preparing for JEE. PW Insider explains centrifugal force. Well, centrifugal force is something like it is called a fictitious force or a pseudo force, and well, they are the same things when it comes to physics. कि इन्हें बताया जाता है समथिंग लाइक दिस। मान लो आपके पास एक चीज़ है जो कि रिवॉल्व कर रही है अराउंड समथिंग। नाउ इफ़ यू हैव मे बी अ काइंड ऑफ बॉल जिसे एक स्ट्रिंग के साथ या एक रोप के साथ टाई किया गया एंड यू आर जस्ट स्विंगिंग इट अराउंड, तब अगर आप यहाँ से खुद देखोगे कि वो बॉल स्विंग कर रही है, यू कैन राइट न्यूटन सेकेंड लॉ ऑफ मोशन। यू कैन से कि इस बॉल पे इस डायरेक्शन में एक फोर्स एक्ट कर रहा है, इसका सेंट्रीपीटल फोर्स जो कि बेसिकली इस रोप या स्ट्रिंग के अंदर टेंशन है, राइट। तो जैसे आपने इसे स्विंग किया, वो बॉल दूर जाना चाहेगी या फिर वहाँ पे टेंजेंशियली फ्लाई ऑफ करना चाहेगी। लेकिन सिंस ये फ्लाई ऑफ करना चाहती है बट इट इज़ टाइड, इट इज़ हेल्ड बाय द स्ट्रिंग और द रोप, तब इस स्ट्रिंग को ये बॉल स्ट्रेच करती है बिकॉज इट इज टाइड एंड इट स्टिल वांट्स टू गो, जिसकी वजह से ये स्ट्रिंग इसे बैक स्ट्रेच कर रहा है बाय न्यूटन्स थर्ड लॉ, एंड इस स्ट्रिंग में टेंशन डेवलप हो रही है या फिर इस रोप में टेंशन डेवलप हो रही है। अब यहाँ पे जो टेंशन डेवलप हो रही है इस रोप में, ये इसे इस सर्कल के अराउंड जाने देती है एंड इट मेक्स इट रिवॉल्व अराउंड द सर्कल, एंड दैट्स व्हाट वी कॉल द सेंट्रिपिटल फोर्स। नाउ ये जो टेंशन इज द सेंट्रिपिटल फोर्स, यूज से कि ये जो टेंशन है ये होगी इस ऑब्जेक्ट के मास टाइम्स में इसके एक्सेलरेशन के इक्वल। द एक्सेलरेशन जो कि सर्कुलर मोशन में हो रहा है यहाँ पे, जिससे अपनी वेलोसिटी चेंज कर रही है, राइट। Now the thing is that this is the centripetal force and you could write Newton's laws in this way, but जब आप खुद उस स्ट्रिंग पे खड़े हो एंड विच यू पॉसिबली कांट डू, बट इफ़ यू एस्यूम कि ये जो हमारी बॉल है बिग इनफ है कि आप खुद उस बॉल पे खड़े हो एंड नाउ यू वांट टू यूज़ न्यूटन सेकेंड लॉ ऑफ मोशन, हाउ डू यू डू इट? क्योंकि अब आपको लगता है कि आप रेस्ट पे हो, राइट। सो नाउ यू थिंक दैट यू आर एट रेस्ट एंड स्टिल यू थिंक कि still you can feel this effect of acceleration. So you think कि यहाँ से कहाँ से फोर्स एक्ट करिए? वेल यहाँ पे इट इज़ इन फॉरवर्ड डायरेक्शन की टेंशन है, हमारी स्ट्रिंग हमें पुल कर रहा है, तो आगे की डायरेक्शन में हमें एक स्ट्रिंग पुल कर रहा है, सो दैट इज टेंशन स्टिल एग्जिस्ट दैट, एंड यू से कि यहाँ पे टेंशन अभी भी एग्जिस्ट कर रहा है, बट वाई एम आई नॉट एक्सेलरेटिंग? क्योंकि ऑल्दो आप इस सेंसेशन को फील कर सकते हो कि आप एक्सेलरेट कर रहे हो या फिर आप पे कुछ फोर्सेस एग्जिस्ट कर रही हैं, so you can feel the sensation but you aren't exactly accelerating with respect to yourself, because when you accelerate with respect to yourself it means you are tearing apart your organs, so you're feeling it but you're not exactly accelerating for yourself, एंड येट वो टेंशन एग्जिस्ट कर रही है वहाँ पे, एग्जर्ट हो रही है फॉरवर्ड डायरेक्शन में। देन व्हाट यू से इज वेल, अब सिंस मैं खुद एक्चुअल में एक्सेलरेट कर रहा हूँ, इवन तो अपने रिस्पेक्ट में नहीं लेकिन किसी दूसरे पर्सन के रिस्पेक्ट में मैं एक्सेलरेट कर रहा हूँ, एंड व्हेन इट हैपन्स तब मैं न्यूटन्स लॉज नहीं अप्लाई कर सकता हूँ, एंड इन दैट केस मुझे इसे एक्चुअली अप्रोप्रिएटली अप्लाई करने के लिए कुछ और फिक्शियस फोर्स का यूज़ करना पड़ेगा। तो दैट इज़ फिक्शियस फोर्स मैं अपनी एक्सेलरेशन के ऑपोजिट डायरेक्शन में लगाता हूँ, लाइक माई एक्सेलरेशन विद रिस्पेक्ट टू द लैब फ्रेम, right, with respect to someone who is not standing on the ball that is revolving around, and when I do that ये मेरी आगे की टेंशन फोर्स को कैंसिल करती है, ये सेंट्रीफ्यूगल फोर्स विच आई कॉल इट, and the centrifugal force cancels the tension force, and well that is a balance with Newton's second law of motion, so that becomes the first law indeed. सो इवन दो वी कैन फील दिस इफेक्ट, देन वी से कि हम लोग ये इफेक्ट एक्सेलरेशन का नहीं बल्कि सेंट्रीफ्यूगल फोर्स का, बट नो इट्स नॉट लाइक दैट, यू आर इंडीड एक्सेलरेटिंग. सो यहाँ पे एब्सोल्यूट मोशन हो रहा है, यू कैन नो विच पर्सन इज एक्चुअली मूविंग, बट यू स्टिल वॉन्ट टू, यू आर reluctant to use any other theories of physics or to accept कि Newton's laws don't work here. So add this concept of a fictitious force जो कि यहाँ पे add कर रहा है, act हो रहा है. So that is the concept of a centrifugal force, the pseudo force that acts in non-inertial frames of reference. Of course, well, when objects are rotating, I mean, forces only act in non-inertial frames. In fact, they don't act. They're there for some mathematical consistencies in Newton's laws. Or BW Insider, if I'm moving just like object revolving, then I can't apply Newton's law too, but I'm not that object, so how will I apply centrifugal force? Well, here I have assumed कि यहाँ पे friction enough है in this particular scenario, friction enough है कि when you're standing on that ball, which you probably of course can't, so that ball can keep you revolving around with the friction. So I have actually assumed something like that, or if it is not, so I've assumed that you are a part of ball itself, or maybe you are in a room that rotates. So that is a much better way to think of it. You are inside a room that rotates itself. So you can always go it like that. So you are going just like the object, and you can apply the total centrifugal force in a room that rotates on yourself individually, and you don't have to worry with these things. PW inside is acceleration, relative, and relativity. The thing is, special relativity doesn't concern with acceleration. ये एक mathematical और physical method था to solve the inconsistency between Maxwell's equations and Newtonian mechanics. तो यहाँ पे acceleration के concept के साथ special relativity wasn't valid because there was no well concept of acceleration in it. General relativity, yes. So there is this principle called the principle of equivalence, जो कि कहता है कि gravity and acceleration are the same things. So what basically acceleration is relative in general relativity, लेकिन यहाँ पे हमें कुछ और well conceptions of gravity add करने पड़ेंगे. For instance, so it's like you can say that, well, I am accelerating in this direction, right? I can say that, and I can say that, and someone will see me accelerating in the forward direction, maybe जैसे मेरी speed change हो रही है, but I might as well say कि मैं आगे की direction में accelerate नहीं कर रहा हूँ, बल्कि पीछे की direction में मुझ पे gravity exert हो रही है. Now the only trouble comes, gravity किस चीज़ की exert हो रही है. So that is of course a very ridiculous way it might seem कि ग्रेविटी किस चीज़ की exert हो रही है, बट अगेन there need not be a thing for this to happen, because well, you have Einstein who comes up with these bizarre ideas which are actually true, that gravity is basically the curvature of space-time and so is the acceleration. So यहाँ पे बेसिकली क्या हो रहा है, जब आप किसी चीज़ के थ्रू एक्सेलरेट करते हो, आप ये भी कह सकते हो कि आप पे ग्रेविटी एक्ट कर रही है. So when gravity is acting over you, you basically say the sun is revolving, the earth is revolving around the sun. So the sun has curved the fabric of space-time, the geometry of space-time, and so the earth is accelerating along this entire thing, and you say किस पे gravity act करी and all that kind of stuff. So that is basically what's happening. It is relative. You need to introduce some conceptions of, well, gravity, of acceleration in it and gravity in it. Karan Nalawat, physics is making notes important, just study from book and solve questions. I guess making notes is important when you need to revisit that thing again. So basically it comes down to, regarding note making, it comes down to आप किस टाइप के लर्नर हो, आपको कैसे पसंद है नोट्स बनाना, या फिर हाउ डू यू एग्जैक्टली लर्न, आपको नोट्स की ज़रूरत पड़ती है बनाने की या फिर नहीं, और यू कैन जस्ट गो थ्रू दैट. दैट इज़ नॉट समथिंग I would say is like absolutely necessary according to me. Yeah, writing it in your language after you have read the material is something that I would say kind of benefits, but solving questions matters a lot. Okay. Arun Singh, age. Well, it's 13 years old. All, or rather, it's A double L. Wait, guys, let him Google. So people just never are satisfied. I mean, what's even the point of satisfying someone? I don't get it. Yeah, PW Insider, distance between objects decrease under real gravity, but distance does not decrease in equivalence principle. Let me just take a moment and get it. What you are saying is कि, well, when two objects are actually attracting each other, as in the Newtonian sense, कि वो एक दूसरे को attract कर रही हैं, and well, that is, if I think you call the real gravity, एंड जिसकी वजह से वो एक दूसरे के टूवर्ड्स एक्सेलरेट करते हैं, एंड वेल दे कैन कम एंड बाउंस अगेंस्ट ईच अदर इफ द फोर्स ऑफ अट्रैक्शन इज like is strong enough for them to come together. But when it comes to principle of equivalence, they don't come together, so the distance doesn't decrease. I think here, see, distance is something like, जो कि हम लोग completely ऐसे सोचते हैं कि it is something like a classical thing. Whenever we think of distance, we think of the classical distance, कि यहाँ पे distance हो सकती है along one dimension, length, breadth and height, but we always forget about the time thing, because when we are doing relativity, well, time is a dimension that needs to be considered. So time needs to be considered well properly. आपको इसे consider करना है even when the distance. Now एक ऑब्जेक्ट अगर यहाँ पे है, दूसरा ऑब्जेक्ट यहाँ पे है, so if they're exerting force on each other and under that kind of gravity, so what basically happens is that they are coming closer to each other and closer to each other, and well, that if they exist at the same time, so the distance of course decreases between them. So yes, distance decreases. Now the principle of equivalence is actually a way to think about it, right? So एज आई टोल्ड यू कि एग्जैक्टली देर इज़ नथिंग जो कि वहाँ पे ऐसा एग्जर्ट हो रहा है, जो कि ऐसा कोई प्लानट है जो कि हमें पुल कर रहा है इन द बैकवर्ड डायरेक्शन व्हेन वी आर एक्सेलरेटिंग फॉरवर्ड. इट्स रादर वे टू थिंक अबाउट इट एंड टू टॉक अबाउट इट मैथमेटिकली. आखिर केवल if electric dipole have two equal and opposite charges, why the charge do not collapse? See, what is basically, जो आप ऐसा assumption consider ही करते हो कि ये charges एक दूसरे के पास नहीं आ रहे हैं, आपने इन्हें hold करके रखा है. So you have actually held the charges at some distance apart. So it is maybe किसी external mechanism के साथ आपने इन्हें hold करके रखा है at this particular distance and at one constant separation, कि दूर नहीं जा रहे हैं, पास नहीं आ रहे हैं कहीं, ताकि मैथमेटिक्स आपकी सिंपल हो. द थिंग इज़, जब यही रियल चीज़ों को कंसर्न करती है, तो क्या डिस्टेंस वहाँ पे चेंज होती है, वो आके कोलैप्स करते हैं? वेल एक्चुअली जो रियल चीज़ें हम लोग कंसिडर करते हैं, वहाँ पे इलेक्ट्रिक डाइपोल का जो सबसे अच्छा एग्जांपल होगा इज़ गोइंग टू बी मे बी एन H2O मॉलिक्यूल, अ वाटर मॉलिक्यूल. तो and since these things are not points at the most fundamental level, ये exactly points तो नहीं है कि इनका कुछ physical size होता है, right? So you have basically one hydrogen, sorry, you have one ऑक्सीजन मॉलिक्यूल एंड इसके दो एंड पे दो ऑक्सीजन मॉलिक्यूल, सॉरी दो हाइड्रोजन मॉलिक्यूल टाइप यहाँ पे टाइड होते हैं, दैट इज़ अ वाटर मॉलिक्यूल. सो वन ऑक्सीजन, टू हाइड्रोजन मॉलिक्यूल्स एट द साइड. अब यहाँ पे सिंस ये अटैच्ड हैं एक दूसरे के साथ, तो इनके सेंटर्स और पास नहीं आ सकती. इनके सेंटर्स और पास आना चाहते हैं, बट दे आर टाइड टू ईच अदर इन दिस when it can't just break the, well, internal composition of the molecules. It's not strong enough to break the internal composition of the molecules itself. That is basically कि ये enough already close हैं that you are not able to separate them, or you are not separating them, and it's well all good in that. And so that is dipole at the end of the day. It's like well, when you consider it naturally in the more physical sense, so that is how, because they will have their own physical shapes due to which they are not really collapsing. Satyam Parichya, it is not known how spin of elementary particles sources gravity. You agree? So quantum gravity is not applicable. Well, yeah, it is not known how a spin of elementary particles source gravity, and quantum gravity is of course not applicable in the current form. Okay, well, we can basically write the laws of quantum mechanics and general relativity together, but we won't be able to solve them for any reasonable answer. So quantum gravity in the current form isn't applicable, and it isn't, well, as we wish to be. So it doesn't exactly hold the way we want them to be, and that is why there need to be some modifications in the theories that will actually make them come together and unify with each other. HI learner, what mathematics we have to read to solve any questions in physics. Now it again comes down to what problems in physics do you want to solve. जो बेसिक फिज़िक्स होती है स्टार्ट करना लाइक एट द 11th लेवल ऑफ 11th और 12th. सो वहाँ पे 11th एंड 12th की फ़िज़िक्स के लिए आई वुड से it's like you just get away, you can just do your basic algebra and trigonometry. I mean that is all you need, right? आपको आपको अपनी 10th तक की मैथ्स अच्छी होनी चाहिए, द 9th एंड 10th की मैथ्स जो कि इनफैक्ट आपको इसके बेसिक आइडियाज़ एंड यू कैन जस्ट डू 11th एंड 12th की मैथ्स. इनफैक्ट थोड़ा बहुत कैलकुलस, इट रिक्वायर्स लाइक द टाइनीस्ट बिट ऑफ कैलकुलस. You just need to know how to differentiate and integrate. आपको इतनी मैथ्स आती है, you can just do 11th and 12th physics. When it comes to more advanced physics, then you need to learn more math topics. So I would say you need to learn more calculus. So it's like multivariable calculus. So you're handling many variables all at once. You have multivariable calculus, you have vector calculus. It's extremely important in electrodynamics. And after that you need some, well, when it comes quantum mechanics you need linear algebra. So it's like extremely important in quantum mechanics. Special relativity doesn't demand as much, but I would say if you want to learn relativity in a, well, more strong sense, you need to know like tensors, because when you're going to do general relativity you need to know special relativity in tensor form. So you need to know about tensors and all that thing. And after that, of course, differential equations is something extremely important. You aren't doing any physics without differential equations. So I would say that is at more advanced level a lot of calculus like multivariable and vector, linear algebra, differential equations. Then you have tensor analysis. Complex analysis is important, so you need to know about them. Fourier analysis, like Fourier transforms and stuff. Rocker, vector calculus really sucks. Now, I would say vector calculus, I think, is difficult for many people. So, I think, well, yeah, the concepts of dive, curl, and gradient aren't really as difficult to first see. Like, I wouldn't place any comments on that as for me. Like I've been doing okay with how much vector calculus I've needed in physics till now. But yeah, I definitely need more for the, like, I still want to solve Jackson's electrodynamics just placed in front of me. And I definitely need more of vector calculus for that. Rocker. Yeah, physics 1 is doable, but maths. Yes, since I have basically learned vector calculus as much as I need to know for doing physics, like electrodynamics to be very specific. I mean, Maxwell's equations are expressed as vector differential equations. So I'm not very sure about how you have been taught maths as sorry, vector calculus when you are actually learning mathematics itself. So I don't know much about that, but I'm pretty sure it's really rigorous. I mean, so, but I think it is also interesting at the same time. Scientific galaxy, why light has dual nature. Now everything basically has a dual nature. So it's like they're matter and waves at the same time. So everything has dual nature. So asking exactly why light has dual nature, we can get on with why everything has dual nature. अब हर चीज़ों को इंटरफेरेंस करना है एंड उन्हें साथ में एमिट भी होना है एंड एब्जॉर्ब भी होना है. So what basically happens is that when you are trying to explain absorption and emission of particles, you are basically using their particle nature. When you're looking at them and, well, actually not looking at them, and you're seeing that they interfere when they go through slits, so you can basically see कि they are actually behaving as waves. So that is why we say at the end of the day, well, they are particles that behave probabilistically. So you may say that particles are probability waves. That is what they are. So this entire concept of matter waves, it's actually that they are probability waves, and that is what matter waves are. So they are probability waves, and the probability collapses when you are observing it or when you are actually interacting with it. So that is what this is about. So they are basically particles materialistically, but they are also probability waves as of their nature. Guido, can light have different nature other than particle and wave? Well, it is very helpful to think of light as field itself. So it's like an electromagnetic field, right? An electromagnetic field that is oscillating, and, well, then you have the creation of photons in that are always traveling at, well, the speed of light. What else? So the thing is that at the end of the day, waves and particles, if someone isn't satisfied enough to know that things are, well, behaving like both waves and particles at the same time, then they need to know that, well, they're all fields, all particles are fields, or all waves are fields, right? So you can basically see that everything that you see around them is somehow interacting with a field, or is a field itself. So that is what basically everything is. So light can be said, well, this is an oscillating electromagnetic field that has momentum and that carries energy with itself. Especially when it comes to the context of quantum field theories, well, then that is extremely helpful, and that is the correct way to view everything. So I would say that that clarifies a lot. And fields, as they can also behave like chunks and like that way, and they also interfere with each other, and that is how that things like light or electrons behave like both and particles, waves and particles. A doll without fin. How can one explain centrifugal force from an inertial frame? Well, centrifugal force itself has its origin in non-inertial frames. So the thing is, you aren't explaining centrifugal force from inertial frames because, well, it balances out the centripetal force to give zero acceleration when you are in an accelerating frame of reference, so a non-inertial frame of reference, so that you can cut out of the equations, you can cancel out of the equations that centripetal force. You think that, well, you are being exerted by an opposite directional force that has the same magnitude, and so that is what's happening. So basically you're thinking of it in this way, and you're thinking that, well, you can't actually explain centrifugal force in an inertial frame because it has its origin, its hypothetical origin in non-inertial frames. Scientific Galaxy, do you know Chitrang Murdia? I'm sorry, I don't. Have you read his research paper on quantum gravity? No, I haven't. I don't know him. I'll be sure to look up. Dvedo, seeing you since you were in class 7. Proud of you. Thanks a lot. Means these appreciations really mean a lot. HI Learner, please suggest physics book for very beginners. What book? How I start physics like you? Well, I started first from some popular physics books like A Brief History of Time, and I started with textbooks like H.C. Verma sir's Concepts of Physics. So I started with H.C. Verma as of textbook, and that I would say would be a good start. A double L, define 1 Newton if you can. I mean, I don't know if you're being sarcastic or something. Like, it ain't even sarcasm. I just can't understand. Well, 1 Newton for you is defined to be the force to cause an acceleration of 1 meter per second square to an object having a constant mass of 1 kilogram. Same thing speaking in the context of, well, a momentum perspective. It is basically the amount of force that is needed to cause a change in the momentum of an object by 1 kilogram meter per second in a duration of 1 seconds. That is what a Newton is, well, in classical physics. A Scientific Galaxy, Chitrang Murdia scored AIR 1 in 2014 JEE Advanced and gold medalist in IPHO. I recommend you to read his paper. He is doing postdoc. Well, I'll be sure to. I'll look him up. HI Learner, what you want to discover in physics? Well, there are lots of theories, lots of things. Feels excite me a lot, but one thing I would again, well, it is everyone's common interest. Everyone who is intrigued by physics, so it's like quantum gravity. You're always fascinated by the subject. Rocker, the force exerted by two straight parallel wires on 1 meter conductor due to magnetic field. This can also be definition of 1 Newton. Well, you certainly have lots of ways to describe 1 Newton. In fact, I can as well say that 1 Newton could be the force that is exerted on a mass of 1 kilogram by another mass of, well, 1 by 6.673 into 10 power minus 12 kilograms at a distance of 1 meters. That is as well 1 Newton. So there are lots of definitions actually. PW Insider, tell true solution of twin paradox. Acceleration is not solution of twin paradox, because twins on rocket will think that twin on Earth accelerated when twin on rocket around Earth. Well, yeah, this has always bugged me actually. It has also always bugged me, the thing with acceleration being the solution of twin paradox. So it's like, well, you think that the object that was accelerated or that felt the acceleration, so he can tell that, well, he was accelerated, and that's why when nature can distinguish between the two, that which one has accelerated by the very fact that one felt the sensation of acceleration. So that is, well, the solution of twin paradox. This has always bugged me, and I have couldn't think of any better solution myself, so I did have to satisfy myself, but I still keep looking for the answer to this, and I hope I will keep looking and someday find the answer to what is the true solution of twin paradox. So thanks for reminding me of one of my 3 a.m. thoughts again. But I don't think I have any other solution of twin paradox right now at this instant. Do we do any other hobbies? Well, I like thinking about physics a lot, about how you are applying various math methods in physics, even when I'm not really sitting down with books and studying. So I like to continuously think about various models of physics, how you can do it all. And besides that, I think I used to previously watch anime, so I've really reduced that a lot recently. I haven't been watching much anime recently. Adarsh Sharma, explain Pascal's law. Well, Pascal's law is about this idea that when you are going inside, well, a liquid or any fluid, such manner, so as you go inside, you'll experience more pressure, and well, you experience more pressure, and this is actually related to the experience to the pressure at the top of the fluid. And how it is related is that, well, the deep well that this pressure at a certain depth is actually the pressure at the top, and that is added with this certain thing right here. And this is basically a certain constant for this liquid and for this planet that you're on, and times this height that you have gone to. So it is that pressure at a certain depth, h is the pressure at the top, plus this rho, that is the density of the liquid, times the acceleration due to gravity, times the height or the depth that you have gone to. um Santoshi Chaudhary, watch One Piece, bro, best anime. I'm sorry, I can't. I don't think I'm ever watching One Piece. It's gonna take lot of time. I can't afford that much time. I mean, in fact, recently I had reduced myself to watching only 12 episodes anime, like the ones having 12 episodes or at max 24 episodes. So I think I do watch sometimes some really long ones, but I'm not watching One Piece. Have you studied electrostatics by David Griffiths? Shamant. No, I haven't studied the electrodynamics by Griffiths. I've well studied quantum mechanics by Griffiths, and well, electrodynamics I read a little from Jackson. Scientific Galaxy, myself, Pratap Singh. Please wish me luck for JEE Mains April. All the best to you and all the ones that will be sitting in the examination hall with you. PW Insider, what is threshold of going into quantum world? There must be a size where both quantum mechanics and general relativity can be used. Well, the threshold to go into quantum world, I think it is a very limiting case, you see. If we connect it with like Newtonian physics, for instance, it's like you can derive the Newtonian results from quantum mechanics in such a way that you write questions, all the equations that you could possibly have for any kind of interaction that is occurring. And then after you have written all the equations in the most perfect sense, you take this limit that the Planck's constant approaches zero, and as the Planck's constant approaches zero, so that is, you're taking this limit when you have taken into account all the interactions and physical occurrence. So this gives you the quantum classical result from quantum mechanics. Now the thing is that the problem with quantum mechanics and general relativity, there is this kind of tensor thing that you have, this stress energy tensor, right? So well, in quantum mechanics, whenever you write something, you write momentum, you actually write momentum operator, right? You're writing position, you mean position operator, or energy, so you say energy operator. So when you write the quantum mechanical laws, so you need to write this regarding this tensor. Or when you look at Einstein field equations that contains, for instance, a stress energy tensor, and you write this thing as a stress energy well operator, then so when you write this as a stress energy operator, the other side of the equation has to well as be an operator. So, but the other side of equation, it just can't seem to be quantified or quantized. That's the problem. One side of the equation will then be an operator. The other side of equation, there are actually terms. So you can basically see that there is something wrong happening. You can't have one side of the equation operators and other sides actual terms that have numerical values. So you're basically saying something like you need to have them as operators as well, but to have them as operators you need to quantize them. So in the sense that you need to know what are the quantum limits. But when you consider that gravity is quantum as of, well, it is quantized in nature at the Planck scale, that theory just doesn't work. And why it doesn't work is that, well, you are trying to do this particular thing, you are trying to just quantize gravity, and the quantum theory of gravity in its correct current form doesn't work, that it predicts lots of infinities and it doesn't give any result, and it predicts results that haven't been seen or can't be physically possible, realistically possible. So that's basically the problem with quantum mechanics and general relativity. I You're having the real joy of physics. Well, yeah, I mean, it's fascinating, it's interesting, and I don't understand that why so many people kind of hate physics. I mean, I can't understand why would people hate something as good as physics. Okay, so here is A double L quantum entanglement. Man, you couldn't find it in Google. First things first, quantum entanglement can be found everywhere on the internet. Now, second thing second, well, quantum entanglement is something that you basically have two particles and they're connected to each other, and well, they can actually influence each other, that is break their states of superposition faster than speed of light. But again, don't confuse it with faster than light the instant you make the measurement. So it's like, well, you can have two things really far off, and you can have one thing, well, as like in a combination of spin up and down, and the other thing in a combination of spin down and up. So one is a spin up, the other has to be spin down, so you have such a combination. So when you measure one thing, one of them, and you say that, well, this is a spin up, and maybe, well, initially it might be in a superposition of spin up and spin down, but when you exactly measure it and you find it in a spin up, then you instantaneously know that at that particular instant that other thing had to be in spin down, that particular instant. So here what basically is happening, that you are actually seeing that information is not propagating faster than light, but you're having information of the other side, well, faster than light is still technically, but it isn't that propagating because it has been with you in your hands all this time. So but you can't exactly tell it to the other person out there faster than light. So don't confuse it with again faster than light travel. It's not happening. But well, yeah, it's interesting that they can influence each other faster than light, and this bonding between the particles, this entanglement is broken faster than the light. ALL, you couldn't answer it in a straight way when I was asking nicely. Well, the thing is, I didn't answer it, right? So, if I didn't answer it, you could maybe wait or something. But, and Shuman Kumar define Fahrenheit uh, pre-rationalization in terms of quantum mechanics. So those kind of traps don't work in here. All right, I know what the terms mean. They were single. Well, I've read about a method through which we could straighten the curves of space-time. Your thoughts on it? Well, so maybe you could publish it or something or describe it. I would be glad to hear. Like if you can do that, and if it somehow explains well this weird nature of quantum gravity. Mohan, can you recommend book for maths that can help to study physics? Well, something like you can just always go with really Hobson and Binns. What I always consult whenever I'm stuck with a maths problem, well, with some mathematical method that is concerning me in physics. So that is, I always refer to really Hobson and Binns. Even though I do hope to learn mathematics separately and well in a mathematical rigorous way. So but I'm doing that after learning a little more physics. Devansh, single, what's your qualification? You look pretty young. Well, I'm in 9th standard currently. I'm 13 years old. So I guess I am young. BW anxiety, can bacteria cause a collapse of wave function in YDSC as observer? I don't think that that's happening because, well, you can always have collapses of wave function in experiments that are not Young's double slit experiments. And well, you're doing them with electrons actually. So you're doing them with electrons, and well, bacteria are themselves made of electrons. So even in experiments outside of Young's double slit experiments, you can still see that collapse of wave function is happening. And how is it happening? You are not able to actually find that out. So bacteria don't really cause that. uh, Nasir Ahmed, photon has no mass, so how can we say that momentum of photon that is equal to mass times velocity when there is no mass? Then how velocity? Well, actually, relativistically, mass or rest mass isn't the only way to say that something has a momentum. Rather, photon has momentum due to the energy in it, right? So photons have energy. In fact, they're bundles, they're packets of energy, and it is due to that energy that photons have, well, this particular, well, momentum that you say. So the correct equation that actually exists is that the energy of an object, so it's the relativistic energy of course, is squared equals the rest mass times the speed of light squared whole squared plus the momentum times the speed of light whole squared. So here the photons have zero rest mass, but they don't have zero relativistic mass. So when they are in motion, so they are basically in motion, and you are saying that, well, in that case they have some well, relativistic mass. But I think the concept of relativistic mass isn't really as beneficial or helpful. It is always better to think in terms of energy and relativistic momentum. So here you can always say that, well, they have certain momentum, and what is that? It is their energy divided by the speed of light. They were single. We used de Broglie equation. I've done a little bit of research on it. Well, yeah, that is what we do. So I think, well, de Broglie relation is something that is really derived actually from the equation I told, the relativistic equation. Energy of a photon is equal to its momentum times the speed of light. Then you put in energy as by Planck's law. So that is the de Broglie relation, right? Yes, Saxena, why charge is invariant? Well, that is a topic that I read more about in, well, future. But as of now, I could say that, well, charge is something. So you're considering the Maxwell's equation. So charge is, well, one way of, well, saying the fields, right? So you might say that, well, charges are what cause fields. But actually, when you consider relativity, you might as well like replace them. So you have a charge and it is exerting force. You can just take the charge out of the picture and you say that, well, this is a kind of field that is existing in this some sort of manner, and the field can oscillate as well. The field can will travel. Now the fields definitely follow Lorentz transformations and, well, Maxwell's equations alongside. So I guess mathematically that would be one way of finding out, by carrying out the mathematical operations, that charges are relativistically, these fields are relativistically may be invariant. But I do hope to read more about that in the future. And I think I really can't explain it in that an easy manner. So I guess we don't understand it, or at least I don't understand it yet that nicely. So that is how we would do, how what we would call it, right? Uh, Here is, Susmit, are you going to MIT? Well, I actually like Trinity College, Cambridge. So that is what I actually like. Though MIT is, of course, like they're as good as Cambridge, or Cambridge is as good as MIT. Well, you have vice versa. So that is, I actually like Cambridge a little more.
Yeah. Question खत्म.
I think there are a few more coming up. The space guy, Sarim, what is the value of E constant? E, do you mean the elementary charge, or by E do you mean, well, the exponential thing? So that constant, whatever you call, I don't even remember what exactly did we call the exponential thing. So if you mean the elementary charge, well, it's 1.6 times 10 power minus 19 coulomb, and if it's the exponential constant, so it is 2.7183. You never know what you're gonna pursue after 12th. Have you thought of joining any university? Hope you don't mind sharing your future plans. No, I don't mind. I want to actually go for Cambridge University, Trinity College, Cambridge. Like, that's what I dream of. Is your favorite scientist Newton or Einstein or Nikola Tesla? Well, I would say Newton, and even Einstein is basically like has had a lot of influence over me, and even Feynman, I would say. Tesla actually not so much. Like Tesla was basically mostly an engineer, and Tesla he was an inventor, indeed a great inventor, of course. So Tesla was a brilliant inventor, but when it comes to physics, so I think Tesla's comments regarding that thing regarding relativity, how he just discarded the theory, so that is I think something that hits me for some reason. Just can't digest that. So Tesla was a brilliant inventor, of course, no offense, but as a scientist, I like more Einstein, Newton, and Feynman. The space guy, what is the formula of angular momentum for a rigid rotating body? So it is, well, the angular momentum. Well, you can consider the angular momentum first for a point particle that is going around a circular path, and you see that, well, this angular momentum can be written as the cross product of its position vector and with its linear momentum. And well, when you can write it that way, so you can add them all up for many such particles, and you can say that, well, the angular momentum of the entire body can be written as the summation of all these individual small particles of this ri, this position vector cross linear momentum. But of course it is not, doesn't really seem that possible to be adding up like using numerical techniques. So you can just carry out an integral over this, so from here to here, and you can integrate this thing, and you have the angular momentum. Or as well, now here you can, what you can do is basically you can also write this thing as the moment of inertia. So you basically have this sum, you can take out some quantities, put in some things, and it's very visible and very apparent actually that it can also be written as the moment of inertia of the body times the angular speed with which the body is orbiting about or rotating about. So you can also write it as this angular momentum and angular times angular speed. So that is another way of doing thing. The scientific Z, have you started general relativity? No, I have to start general relativity yet. I have to study it. All in one text. What do you like the most, astrophysics or quantum mechanics, and why? Well, I think I would like quantum mechanics more than astrophysics, even though astrophysics has been quite interesting. But well, quantum mechanics actually, astrophysics uses quantum mechanics, of course. So I always want to understand that where are you using these things. So whether it's quantum mechanics or relativity or any other thing, so you're using them in astrophysics or what field. So regarding the study itself, what I found more enjoying or uh, or well, kind of interesting, so I would say studying quantum mechanics itself has been a little more interesting than studying the applied science astrophysics. The space guy, bro, you should read The Grand Design, Sarim Khan. Well, yeah, I have read that book and I loved that one a lot. The Grand Design by Stephen Hawking. I really loved that one a lot. I mean, the way it has been written, and it explains complicated things, even though it is a popular physics book. But it is one popular physics book that is definitely worth the read by everyone who is studying textbooks or whatever. You should always once read that one. So I think we should stop right now, right?
एक इसका देख लो अगर आता है तो
So
सुमे
happy.
what is the effect on the interference
Wait a minute. The scientific Z considers studying invariance, covariance, and contravariance before starting GR. Well, really thanks for the advice. I'll be sure to. I'll look up to it and I will definitely read it before general relativity. What is the effect on the interference fringes in a Young's double slit experiment if the monochromatic source S is replaced by a source of white light? Well, you're still having fringes there. You're still having fringes there, and it's because, well, when you have this source of light that is going in that particular thing, and it is passing through the two slits, and it lands at over there at the screen, it will still have fringes, for the reason that you need to understand that why these fringes are actually just existing there, and it's because when the light from these two different sources now, because, well, you have basically cut out the light in two parts, and now these sources have actually these slits themselves have become sources of light, and as they will go forward, the waves will interfere with each other, and you see that the waves are now interfering with each other. So at some points you're having addition of amplitudes, at some points you're having, well, cancelling of amplitudes, due to which the white light is still going to, well, interfere with another white light of the same symmetrical kind, and, well, due to that reason, at some points you're seeing that these fringes are still going to be present there, and, well, that is, well, basically because of the interference again. So it is still, and it's really fascinating, I suppose, and you can always look at that and wonder and see that how fascinating it can be. Well, you can actually prove that white light is a sum of all kinds of lights, and that, well, lights are waves and they're interfering with each other. They can as well be called particles, and you can understand them from the particles perspective by considering them as probability waves. This is kind of exciting, I think. So in that case, we'll just end it at this one. It's been like 1 hours and 18 minutes, and so here we'll end it at this only. I think I have already spoken a lot today. So that was all for today's stream of mine. We'll be sure to come with another, and we'll be sure to answer more questions. And thanks to all viewers.